Okay, as promised, guys, I wanted to make you some videos on Miniquiz number 3. Now, we have a final coming up in a few days, so you better study and listen carefully to everything I do, write, and say. Here we go. So, on number 12 that I gave you, you'll notice that we need to make a confidence interval. Now, what information are we given? We're given that one sample was size 1018. The other random sample was 1013. In the first sample, it says that 22.3% reported that the wife was the primary earner in the family, right? And let's see, wait a minute. Oh, I missed it right there. So anyway, let's just read the problem. It says in 1960, they did a study. They took a random sample of 1,018 families that consisted of husband and wife and at least one kid. Of those families, 5.8% reported that the wife was the primary earner of the family. Only 5 to 6% basically back in 1960. In 2011, they did the study again. They did 1,013 randomly selected families, same situation, man, wife, and child. 22.3% had the wife being the main breadwinner. And we want to make a 99% confidence interval. So, because these are proportions, guys, you should know it's an automatic Z. And we're going to come down here, and we know that 99% is 2.576. That's the Z star number. So, long story short, if we want to make a test statistic or interval in this case, we're going to compare them by subtracting them, right? So notice all of these are set up correctly for the point estimate part. We call this the point estimate, right? The initial difference in this case. But we want to look either here or here because those are the only two at 99%. So if you look carefully, this one is set up the way we learned it. Remember that standard deviation is going to be the square root of P1 minus P over N, like so. And that's what you see here and here. And here's another hint. Notice when we combine them together, basically we did Pythagorean theorem, right? We did A squared plus B squared. A and B being the individual square root standard deviations. We squared them, and then we square root that to find our new standard deviation. So remember, standard deviation combines using Pythagorean theorem. Please ask me in class if that still confuses you. We only have a few more days. Okay, 13. Researchers investigated whether a new process for producing yarn reduces the mean amount of these poisons. From random samples of carpets, researchers found that the mean reduction made with yarn produced by a new process made the yarn was 13 parts per million. All the conditions for inference were met. The p-value for the appropriate hypothesis test was, here's the key point, right? Almost 10%. Which of the following is the best interpretation of this p-value? Now, guys, this is kind of a tricky because when we discuss this in class, hopefully you were there. Remember, what you do is on any test or anything, you assume H naught. And so when our p-value came out to be 0.095, that's telling me we only have a 9.5% chance that H naught actually was satisfied. Okay, so A looks like a very tempting answer. It's a very good answer, actually. Notice on B, they're trying to trick you. The alternative is what we're trying to indirectly prove. That one technically would be almost 90% chance of happening because we'll do the complement of that, right? C, the probability of observing a mean reduction. No, that's not what it means. Okay, So what's the better answer is D. If the null hypothesis is true, remember that's what we're assuming, the probability of observing a mean reduction, and we got a value of 13, well, that chance of that happening, see, it's the value of 13 or more is 9.5%. And that's the key thing to understand. This one is a good answer, but D is the best answer. Please again bring this up in class if you're still confused by it. You need to think about it, guys. This is a thinking, rationalizing kind of class, right? Okay, 14. Researchers working for a certain airline are investigating whether the weight of carry-on bags, The researchers will use the mean weight of a random sample of 800, and then they did a random sample of 1,300 the next time. Well, what I want you to learn, guys, is bias is a term that we haven't officially learned together. I haven't directly taught you bias, but just know that bias is something that's, as we say, inherent in the data. Okay? So bias is basically not going to change. All right? The key thing to understand, though, we could control the amount of variance, or remember, variance is standard deviation squared. Literally, if I said the variance was 9, you know the standard deviation is the square root of 9, which is 3. They have that squared square root relationship. And so they basically mean the same thing. It's basically the average amount of spread or distance from the mean, right? The more the data is spread out, the farther on average they're going to be from the middle mean. Hence, it will have a higher standard deviation. But the whole point, and remember this, I hope you've been watching and studying this video for me, because this is going to come up on the exam. The larger we make our sample size, the smaller the variance. So in other words, I hope you're paying attention. If we started out with, let's say the variance, I'm just making this up, was 100, or let's start out that way. Let's say the variance was only 2. Our data would look something like this. But if I changed from 2 to 10, you would see the data get narrower. If I changed variance from 10 to 100, you would definitely see it narrower. So the larger the sample size, the smaller. Because remember, just think of how we calculate standard deviation, or I should say, standard deviation is, remember, we're dividing by the square root of it, whether we're doing a proportion or a mean. But long story short, let's get to the answer here. The bias will decrease. Well, remember, bias is not going to change. It's inherent. So we can already eliminate A and B because it's not going to increase or decrease. All right? Bias. So we're actually down to C or D. See, we're both of them, the only two that says bias remains the same. And since I increase the sample size, variance will decrease. That's why you should have chose C. All right, one more and we'll end part 1 of this video. 15. We're trying to do a 99% one sample Z interval. And the key thing is we have a sample size of 1,000. They're saying, well, what happens if we increase it to 4,000? Notice that 4,000 is 4 times 1,000, right? So, and because of, let's say it's a means. Is it actually a means or a proportion? Okay, let's assume that it's a means. Well, remember, we always divide by the square root of n. So therefore, since we made it 4,000 from 1,000, we made it literally 4 times larger. Hence, the standard deviation is going to get smaller and shrink by the square root of 4, or twice as much. So that's why I believe the correct answer is E. The margin of error for R will be twice the margin of error S. S was a 4,000, will literally be half as large. So they're playing on words there, so be careful not to confuse it with B. R is going to be the larger one at 1,000 sample size, whereas S will have half the margin of error of R, right? So again, any of these questions, guys, please bring them up. It's worth discussing again in class. And believe me, a classmate of yours will probably thank you for it. So I'll see you in class, a couple days to the final. Make sure you're watching and studying this video. Maybe watch it more than once. Problem by problem, all those little hints I threw in there, make sure you know them. See you in class.